Hello all. In today's class we are going to discuss about structure of LEX program. There are mainly three sections. The first section is called as a definition section, and the second one is rule section, and the third section is called as C subroutine. So let us look into the structure of LEX program with a simple example. So this is called a definition section, which is been enclosed with delimiters of these two types, and there is a separator between the definition section and the next section with double percentage, indicating that it's a separate section. Similarly, a rule section is separated by the main section with the help of double percentage, and these two again a rule section is written within this. Finally, the main section is having a main function called YY to call the LEX part. This is called as C code section or subroutine section. A simple LEX program is just to print as it is. Whatever you give the input, you are going to just print it on the screen. So for that, we are writing a definition in a rule section like this. These two are the separators for rule section, as well as before that you can also include definition section, which if it is required for your program. So this is the rule section, which has mainly two parts in it. The first part is called as pattern. You have to define by making use of a regular expression. Then for every pattern which is getting matched with the input, you have to have some actions like this. Either you can have printf statements, you can do anything whatever you want as an action here, okay, which has been ended with semicolon. Here what is the pattern we are defining? You are already knowing that dot is getting going to match with any character, single character, or a new line. A dot is a meta character which has been already defined to recognize or recognize any single character which has been given by the input, and a new line is the one pattern is going to match with the new line in the input string. So but this is not going to match the new line, that's why you have to specify both. So whatever you give input, anything, this is going to match anything other than new line. Therefore, so it's going to match with any of the input, including space, tab, whatever you give, any alphabets, any word strings, whatever you give, it is going to match with every single character. Or if it is even new line also, just echo indicating that you are just printing on the screen as it is. So this is the simplest LEX program that you can define. It is just similar to a cat command with no arguments in Unix. So you might have already used this cat command in the Unix. So it's same as this one. Now let us move on to how to run a LEX program. This is also very important in this LEX and YAC part. You need to also understand why we are doing all these steps for LEX program as well as YAC program. That is a major part here. It is also equally important like your program. Very first thing is you need to save the program with .l extension. Once that is done, say for example filename.l. So that is your filename.l is your LEX program. Next, the first compilation step is to LEX. You have to use this command LEX space filename.l. You have to first compile LEX program. Once you compile this, this is going to produce equivalent LEX file. The name of the LEX file is called as lex.yy.c. This is a small letter LEX. lex.yy.c is the equivalent file of the file name which you have defined in LEX. It's a C file. Since it is a C file, you need to compile the C file, okay, by linking the LEX library. So for that, what you should do is cc is the command for compiling the C file, and the converted C file is here lex.yy.c. Give the file name, a space, minus ll or hyphen ll, indicating that linking to lex library. Once this is done, this step is going to convert your file into executable file. The name of that file is a.out. Since you have to execute this executable file to see the output, you have to also include dot slash. That means your output, this output file may not be in the same current directory, so you need to use the root directory path dot slash a.out, which is going to fetch this file and execute it. Once this is done, you will be able to see the output. And you can also change the name of this a.out by using this simple step, that is cc lex.yy.c minus o, the new underscore output file name. You can give any file name that you want to give, hyphen ll. That means minus o is the option to change the executable file, because this is the default executable file. So we have another example here which also includes additional functions. So let us see here. It's a rule section. This don't have any definition section because you're not using any variables or any header files is not required. So that's why we are just doing match everything except new line. So for that, pattern which has been already learnt is dot echo it, print as it is. Similarly, for matching the new line, slash n and echo. So this is the rule section. So in that, this is part is called as a pattern part, and this part is called as a action part. This part is called as an action part. Okay, next, in case if it is not getting matched with this, the program has to throw an error. So you can also include functions like int y_wrap void, which is going to return 1, and also in the main function, if it is valid in the main function, you have to call the function called y_lex. So this is the built-in function lex file. This is going to create the lex file, and this is going to get matched with the input string, and it's going to print the output. And if the valid one you are doing, then it is going to return 0, otherwise it is going to return 1. So moving on to simple another example, which is most important even exam point of view. Lex program to count the number of vowels and consonants in a given string. So given a string, you can identify how many vowels are there, how many consonants are there in that. So for example, if this itself is my input string, then what is L, what is E, what is X, you have to count it here. Number of vowels, how many are there. Similarly, number of consonants, how many are there, you have to print it on the screen. So for this you need a variable, 2 variables, so that's why I can use description or definition sections, where within the delimiters you can have int vowel count as 0, initialized to 0. Similarly, consonant counts as 0. Do these two, then do a rule section separator. So within the rule sections you have you can write the pattern for the identifying the vowels first. Then if it is not a vowel, then obviously it can be called as a consonant. Okay, so first write that vowels, A-E-I-O-U small letters, A-E-I-O-U capital letters. Within the character class you can define. So this is the one of the pattern that we are defining for vowels. Okay, so whatever you write within this, it's all called as vowels. Okay, either it can match with this, match with this, match with. Okay, so vowel count increase. So if not this, it can come in any one of this, then it is going to be called as a consonants. So this is all about rule section. Then y_wrap is a function which is going to throw an error. In the main part, again enter the string of vowels and consonants, ask the user to enter it. Then y_lex, call the main function y_lex, which is going to call this. And finally, once this is done, the counts will be having the values, you just print them on the screen. Okay, thank you.